Hello and welcome to another video on Cambridge International A-Levels Mathematics. Today we're solving a trigonometry question. This is taken from past papers. It's a very old one and it's a very hard one. So I hope you enjoy. If you have any questions, you can ask me in the comments below. And without any further waiting, let's start. Alright, here it is. So first of all, this is from A-Levels Mathematics Year 2. So if you're from Year 1, maybe this would be too advanced for you. So come back to this video next year. Anyway, let's start. So we have solved the equation cos of x plus pi over 6 times cos of x minus pi over 6 is equal to cos 2x, and we have to solve this for x between 0 and pi. I have written some useful stuff here which I will not explain in this video, but hopefully you already know all of this. So I just wrote it here in case you forgot, and I will be using these formulas in this question. Anyway, so let's observe what do we have here. We have cos of something like a plus b, and then we have another cos of something like a minus b, and we can expand these using these two formulas, and that is a good first natural step. We can expand it and then simplify. This will definitely lead us somewhere. So let's do that. We have I'm using equation 1 and 2. So we have cos of x plus pi over 6. This is equal to, according to this formula, number 1, we have cos of x cos of pi over 6 minus sine of x sine of pi over 6. And I know the values of cos pi over 6 and sine pi over 6. So this is equal to square root 3 by 2 cos of x, because cos pi over 6 is root 3 by 2, minus 1 over 2 sine of x, because sine of pi over 6 is 1 over 2. We can do the same thing for the other cos. We have cos of x minus pi over 6. This is equal to cos of x cos of pi over 6 plus, this time not a negative sign but a positive sign, sine of x sine of pi over 6. So for this one I have used the second equation here, and once again I know the values of cos pi over 6, root 3 by 2, and I know the value of sine pi over 6, 1 over 2 sine of x. Let's plug these back into our equation. So we have these two cos here. I will write these brackets. This is equal to the right hand side of the equation, which was cos of 2x, and inside these brackets I will just copy and paste whatever I found. So this one comes here, and this one that comes here. Okay, now we have to multiply. You can expand these out term by term and then combine the like terms. What I will do is use equation 3. So I'm using equation number 3, and what is it? That is a plus b times a minus b. It's equal to a squared minus b squared. So I'm sure you know of this, and we have the same form in our question. We have something like a minus b, a plus b. So we can write this as a squared minus b squared. Let's do that. So a squared is square root 3 by 2 cos of x squared minus b squared is 1 over 2 sine of x squared. This is equal to the right hand side cos of 2x. Let's apply these squares. We get 3 cos square x over 4 minus sine square x over 4. This is equal to cos of 2x. I will now copy and paste this on the next page. I'm running out of space, so let's go here. Right, so now in this step I will multiply both sides of the equation by 4 just to get rid of this denominator. And what else I will do in the same step is to get rid of this sign, because in trigonometry questions, whenever we have to solve trigonometric equations, it's always advisable to reduce the number of trigonometric ratios present. So in this equation we have cos, but we have the sign here. So it would be nice if we can convert this sign into cos. So in the same step I will convert this sign into cos, and let's see what happens. So 3 cos square x minus, instead of this sine square x I will write 1 minus cos square x. That's another trigonometric identity. This is equal to 4 times cos of 2x. Now let's expand. 3 cos square x minus 1 plus cos square x this is equal to 4 cos 2x, and we can combine these two terms, this one and this one. So this is equal to 4 cos square x minus 1 is equal to 4 cos 2x. Okay, now what do we do? Now what's the problem? What's the issue? The problem is we have cos square here and cos 2x here. So it would be nice if I could somehow convert this cos square into cos 2x, or I could convert cos 2x into cos square. And luckily I can, so I will be using equation number 4. Using equation 4. And what is that? That is this one. So cos 2a is equal to 2 times cos square a minus 1. So let's write it here. We have cos 2a equals 2 times cos square a minus 1. And you can use this to convert either this cos 2x into a cos square, or you can convert this cos square into a cos 2x. So what I will do is just plug in the value here, because that is easier, simpler. So we get 4 cos square x minus 1 is equal to 4 times, and what is the expression for this? 2 cos square x minus 1. Let's expand. We have cos square x, 4 cos square x minus 1 is equal to 8 times cos square x minus 4. And now it's just a matter of isolating cos square x on one side. To do that, I will add a 4 on both sides, and I will subtract 4 cos square x from both sides as well. So 4 cos square x. So what's the result? We get a 3 on the left side, and here we get 4 cos square x. Now divide the equation by 4 on both sides like this, and we get 3 over 4 is equal to cos square x. And now we can take a square root on both sides, so square root here and square root here, and in the end we get cos of x is equal to plus and minus root 3 over 2. So it's not one equation, it's actually 2 equations which we have to solve, once with the positive sign and once with the negative sign. So we have cos of x is equal to positive root 3 by 2, and cos of x equals negative root 3 by 2. But luckily for both of them, our basic angle alpha, we have to find the basic angle now. So the basic angle alpha, it is equal to cos inverse of root 3 by 2, and cos inverse of root 3 by 2 is equal to pi over 6. So we found the basic angle. We can now use it to find the values of x. I will copy this last part to the next page. Right, so for this first one, since cos is positive, we have a positive sign here. So cos is positive in either the first or the fourth quadrant. So our solution, the value of x, has to lie either here or here. Similarly, we can do it for the other equation. So cos is negative in the second. Let me straighten this up. Yes, so in the second and the third quadrant. But we can get rid of 2 of these quadrants, because in the question, if we go back, it says that we are looking for solutions of x between 0 and pi. This means that we don't want any solutions here or here. We're only looking for solutions in the first quadrant or in the second one. Right, so first one is very easy. For the first quadrant, x is always equal to the basic angle. So x is equal to pi over 6. And for the second quadrant, x is equal to pi minus pi over 6. That is pi minus alpha. Alpha is pi over 6, which is 5 pi over 6. Why do we do pi minus pi over 6? Because we're looking for a solution in this quadrant. Let's remove this a bit. And here is our solution. This is the value of x. And the basic angle alpha is the angle with the nearest x-axis. So this is the angle alpha. So x is equal to pi minus alpha, and that's how we get pi minus pi over 6, which is equal to 5 pi by 6. So these are the 2 solutions, and this is the only 2 solutions that we will get, pi over 6 and 5 pi over 6. So that is it for this video. I hope you enjoyed solving this question with me, and if you have any questions, you can ask me in the comments below, and I will see you next time.